Recall that the internal energy of a substance is the sum of the kinetic, potential, and other kinds of molecular energy the substance has. Heat is energy that flows between two objects with different temperatures. When a substance participates in a process involving energy in the form of work and heat, the internal energy of the substance will change. The relationship between work, heat, and changes in internal energy is known as the First Law of Thermodynamics. We will see how this relationship is just an expression of conservation of energy. There are two ways to change the internal energy, U, of a system. The first way is to add or remove heat, Q, from the system. If we add heat to the system, the internal energy increases. If we remove heat from the system, the internal energy decreases. The second way to change a system's internal energy is through work. If the system does work on its environment, and there is no heat flow, then the internal energy of the system decreases. If the environment does work on the system, then its internal energy increases. A system can gain or lose energy simultaneously in the form of both heat Q and work W. The change in the internal energy, delta U, due to both of these factors is given by the following relationship and is known as the first law of thermodynamics. It is just a statement of the principle of conservation of energy for heat, work, and internal energy. The internal energy of a system changes from an initial value, U initial, to a final value, U final, due to heat Q and work W, where Q is positive when it is gained by the system and negative when it is lost by the system. W is positive when it constitutes work done by the system and negative when it corresponds to work done on the system. In the first law, the internal energy U, the heat Q, and work W are energy quantities, and each is expressed in joules. However, there is a fundamental difference between U on the one hand and Q and W on the other. The change in internal energy, delta U, is determined once the initial and final temperatures of the system are established, since temperature is a measure of internal energy. Thus, temperature is one of the variables, along with pressure and volume, that defines the state of the system. The internal energy depends only on the state of the system, not on the method by which a system arrives at a given state. In recognition of this characteristic, internal energy is referred to as a function of state. In contrast, heat and work are not functions of state, because they have different values for each different method used to make the system change from one state to another. For example, the same change in internal energy of a system could be created with many different values of Q and W.